வணக்கம் நண்பர்களே, மீண்டும் ஒரு வீடியோவில் சந்திப்பதில் மகிழ்ச்சி. ஸோ இன்னைக்கு கிளாஸில் we discuss about self induction and mutual induction we have to discuss. Okay, and mutual inductance induction. So what is the basic definition for induced EMF? Then basic principle, then changing current, then changing current na, then changing magnetic flux. Then EMF is induced. So this is the basic. So next we move on self induction. So I have to write first formula, then self inductance is equal to minus L by then change in current with respect to time t. So this is the most important. Okay, so in the formula which problem make here, then how to write here? L is what is that? Then self inductance, then negative sign indicates for, the negative sign indicates Lenz law. Okay, Lenz law. Okay, so it opposes changes. Okay, then how to write for definition? Then EMF induced in a coil, here single coil, because of self inductance due to change in its own current. Change in its own current. Okay, this is the self inductance. Upper we have to define self inductance L. So இதெல்லாம் sometimes problem கேட்பாங்க. Okay, or sometimes they should be asking direct question. Self inductance, how to define? Then self inductance L is equal to then N flux divided by current. Here L is the self inductance. Okay, so then similar way we have to define for mutual inductance. Okay, so next mutual inductance. Then how to define a mutual inductance? I have to write equation, then E is equal to then minus M di by dt. Okay, so this is most important. Here M stands for mutual inductance, then change in current with respect to time. So the negative sign indicates for Lenz law. Similarly, then how to define? Then EMF, இங்கே வந்து மியூச்சுவல்னும் போது we have to use two coil. Then EMF induced in one coil due to current change in another coil. அப்போ similar way how to write mutual inductance? Then mutual inductance M can be write it as then N2 then 2212 divided by I1. Okay, so why we have to put here 2 to 1? Here we have to use two coil. So then before the cases self inductance we have to use one coil, and we have to put no need any numbers. Here we have to use two coils, then only we have to represent 2 and 1. Okay, so this is the definition for self induction and mutual inductance, similar for self inductance and mutual inductance. So some of the important point we have to discuss. Okay, next is some of the important formula we have to discuss. Okay, then energy stored in inductor. So I have to straight away to write the formula. Then U is equal to then 1 by 2 then n I square. Okay, then problem போடும்போது you have to understand. Then similar, this is the first one, then second one, then long solenoidal, that is the most important, long solenoidal. So the long solenoidal L is equal to then mu naught mu r then n square then a by L. Okay, up here where n is the number of turns, then A is the cross sectional area, then L is the length, then mu naught is the permeability, that is the important permeability of free space, then mu r, that is relative permeability. Okay, so these are the most important formula you have to remember. So next நம்ம ப்ராப்ளம் போடும்போது இதெல்லாம் யூஸ் பண்ணுவோம். ஓகே, ஸோ நெக்ஸ்ட் கோஎஃபிஷியன்ட் ஆஃப் கப்ளிங். Coefficient of coupling formula, then K is equal to m by root L1 L2. Okay, so the condition then 0 lesser than K lesser than 1. Okay, for perfect coupling, then K is equal to 1. Okay, so next units and dimension, most important, then units and dimensions. So then self inductance, so then symbol, then SI unit. So what is the self inductance symbol? Then L. What is the unit? Henry, that is H. Then second, mutual inductance. What is the symbol? M. What is the unit? Henry. Then induced EMF, volt. Okay, so most important. So the definition of that should be the direction of induced EMF which is opposed the causes, which is called as Lenz law. Okay, then same coil and then I have to write some of the point. Okay, so if it same coil na, so same coil na to use, that is self inductance. If two coil irundhuchna, to use mutual inductance. Okay, then faster change in current, then we have to get larger EMF. We have to discuss in the last classes. So self inductance na one coil, then mutual induction na two coil every negative sign, then oppose pannom, then unit of self inductance and mutual inductance is Henry. Okay, that is the important point you have to remember. Okay, so these are all the point you have to remember. So next we move on to the problem part. Okay, next this is the one of the problem, for example self inductance. Okay, so if you see that from this problem, a coil has a self inductance. Okay, that is the important. Okay, then self inductance of 2H, if the current in a coil changes at a rate of 3 amps second inverse, then find the induced EMF. So then how to solve this one? So what is the formula for self inductance? That is E is equal to then L di by dt. Up here what are all the given? So given enna kuduthirukanga, so then inductance L is equal to then 2H, then similar then change in current with respect to time, then di by dt, which is equal to 3A per second. Okay, so just we have to substitute in this formula. So by substituting the value, then E is equal to then L என்றது there should be a 2 into then change in current with respect to time, there should be a 3. Appo then E is equal to 6, that is 6 volt. So this is the simple problem. அப்போ நம்ம என்ன தெரியணும் நம்மளுக்கு? So this is the formula. So formula தெரிஞ்சாதான் நம்ம போட முடியும். Okay, so that's why I have to concentrate on equation and formulas. Okay, then similar way we have to move on the another problem. Okay, so okay, the same problem I have to give one of them, you have to do it yourself. Okay, if you take this one is homework. So the same format I have to give the another problem, you can do it.